Good afternoon, everyone. Welcome back. Today we are going to talk about dispersion and mean deviations. Okay, so we are talking about measures of central tendency. We have talked about arithmetic mean. We have talked about median. Then we have talked about geometric mean, harmonic mean. So we have talked about all these. And now today we are going to talk about dispersion and mean deviation. So let us dive into it. Yes, Bhargavi, Ishan, Sonali, Lakshita, Jyoti, Rafika, Ashpavu, Rohini, Mohammed, Vibhu, Nital, Sanjana, and Rohini. Okay. So now let us go into this. Now, what is dispersion? Okay. So let me show you. Suppose I have my data and I plot my data, and when I plot one graph, it is looking like this. Okay. Okay. And for the other graph, it is looking like this. Now, if you try to find the mean of both is the same. Okay. Mean of both is the same. But as you can see, this is more of a flat curve, and this is more of a bell-shaped curve. Last time we have done about different types of curves. Okay. So this is a little flatter and this is bell-shaped. So do you mean that both the data are same because the mean is the same? The answer is no. Okay. What we say is their dispersion is different. Okay. We then say that their dispersion is different. So two distributions may have the same central tendencies but different dispersion. That is their scatterness. Okay. What is the word scatterness? It may differ. Okay. What does scatterness mean? It means that how stretched out or how squeezed your data is. Okay, so that is known as dispersion, and that is very important when we are trying to find out when we are analyzing data that is available to us. For example, like if I'm manufacturing something and there is error in making that maybe a small screw. Okay, so if I'm manufacturing a screw, so what is the error? So let me see. If the error is very narrow, it is good. If it is very large spread, we don't want that. Okay. So similarly, we have various different examples in practical life where the dispersion calculation is helpful while making decisions. Now, how do I measure this dispersion? It measures a variation of the data around one of the measures of central tendency. Like we will find dispersion around mean or around median. Okay. And then there are two types of measures. The first is the absolute measure and second is the relative measure. Now, in absolute measure, which measures the dispersion in the same statistical unit. So, it measures in the same statistical unit, while the relative is a ratio. Okay, it's a ratio. And which are the measures of absolute measures of dispersion? Those are range, mean deviation, standard deviation, and quartile deviation. So when you have absolute measure of dispersion of range, then coefficient of range will be its relative measure of distribution. Then mean deviation, it will be coefficient of mean distribution. Standard deviation, coefficient of standard deviation, and quartile deviation, coefficient of quartile deviation. Okay. So these relative measures of dispersions are more useful, but they are a little more complicated to calculate. And so therefore, but we will be using both of them. I'll be showing you examples of both of them for you to be able to understand. Okay. In this, the first, okay, so we have range, mean deviation, standard deviation, and quartile deviation. So of that, first we are going to talk about range. Range is a simple measure of dispersion which is defined as the difference between the largest value and the smallest value. So simply, When I have just some data, some discrete numbers, and I just want to know um, an overall view about what is the range. Okay, so a little understanding of how the data is. For example, when your teacher, she's giving you marks for a subject, so maybe you've got marks of accounts, then what do we do is that we will have to know what is the, how was the paper, how did the students do. Okay, so some other teacher may ask, so this teacher will tell you, okay, the marks are ranging from 40 to 100. Okay, marks and accounts are ranging from 40 to 100. How did she calculate that? She just took the student who got the highest marks. She took his marks, and then she took the student who got the lowest mark. She took his marks, and then she subtracted them. So that is range. Okay, simply put. So range is equal to largest minus smallest. Okay. When you have this, then we say that the coefficient of range, okay, that is the relative measure of dispersion, coefficient of range is equal to L minus S upon L plus S into 100. Okay. Now, important property, this is important. Okay. Sometimes you get questions on this. Range is unaffected by change of origin, but it is affected by change of scale. So origin not affected, scale yes. So what is the formula when it is affected by scale? It says that Ry, that is the range of the new variable, will be equal to B into Rx. Now what is this B? We say y is equal to a plus bx, and then we take the mod of b into rx. Okay, so ry will be mod of b into rx. Why we have taken mod is we are not considering the sign, we just want to see the magnitude. Okay, so ry will be mod b into rx. We'll be doing sums on it, so there you will be able to understand. Okay, so first we have talked about range. What is range? Range is simply the largest value minus the smallest value. What is the coefficient of range? L minus S upon L plus S into 100, where L stands for largest value, S stands for smallest value. And the third thing we have talked about is that range is unaffected by change of origin, but it is affected by change of scale. Ry will be equal to B into Rx. Okay. Now we'll take some examples. In the PPT, because I took the questions from the old module, so the question number is coming as 15.2.1, but now you can refer to the new model. So only the 15, instead of 15, you have the number 14. So the question number remains the same, but instead of 15.2.1, it is now 14.2.1. Okay, so here I have put it that way. So you can just refer to this video again when you want to check out when you want to practice the questions. Okay. Now following are the wages of 8 workers expressed in rupees. Find the range and also the coefficient of range. So in this case, what we are going to do is we are going to identify the smallest and the largest. Now let us see. Smallest is here. Can you tell me the smallest number, everyone? And can you tell me the largest number? Yes, Zeba, good afternoon. Maida. Adish, yes. Swati, yes. Chahal, Soumya, Shivani. Now, can you tell me the smallest number? So, can you tell me S is equal to how much? S is equal to how much? L is equal to how much? Then I will say range will be equal to L minus S, and coefficient of range is equal to L minus S upon L plus S into 100. Yes, L minus S, L is how much and S is how much? Okay, Aditya saying 50 and 96, Megha 50. Tejashvi, 50 is the smallest number. Yes, Chahal. Vanshika. Yes, Avdesh, Koshti. Yes, Tejashree 96 is correct. Mono, yes. Okay. Yes, Sagar. Yes, Pratidnya. Avinash. Avinash again, 50 is the smallest number. So this will be 96 minus 50. Answer will be 46. Okay. And this is how much? 46 upon 96 plus 50 into 100. Now how much is 96 plus 15? This is 46 upon 146 into 100. So can you tell me this answer? What is the percentage answer? Yes, Ashdeep, 92. Ashdeep, there is no 92 over here. Adish, please check the website. 31.5, Lakshita, Ustad, Avdesh, Vishnu. Vishnu, you've got 36.5. Okay. 46 divided by 146. 31.5. Okay. So this will be the answer. Now second question. Okay. Yes, Sakshi, range is Sakshi answer is correct. Masum, Gunjan, yeah. Very good. Now let us do this for the second question. Now, whenever you have frequency distribution, how do I find out? So first step that you need to see is whether it is a continuous or not. Now, is it continuous? 50 to 54. Now 54, after that the second interval is 55 to 59. So I have 50 to 54, then 55 to 59. So it is not continuous. So what should I do? I should make this first continuous. So what will be the first interval? First interval. So if it is not, if not continuous, make it. Okay. So what do? I will. What is the difference? 55 minus 54. This is the difference upon 2, which is equal to 0.5. Okay. So to make it continuous, I will need to use this. So what will be the class intervals now? Weights in kgs will be 49.5 to 54.5. Then second will be 54.5 to 59.5. Okay. And so on. We will just do this for the last one. So it will be 69.5 to 74.5. Okay. So from this, what is my largest value? Largest value is 74.5 for this class interval, for this frequency distribution, and smallest is this much. Okay. So now I can find the range. So range will be equal to 74.5 minus 49.5, which is equal to, can you tell me what the answer will be? Yes, Avdesh, 74.5 is correct. 49.5 is correct. Okay, so can you give me the answer? Bibika, that is the final answer, coefficient. Now, how much is this? 25? Okay, very good, Avdesh. And their coefficient of range? Will be how much? 25. Okay, upon 74.5 plus 49.5 into 100. So this is how much? Yes, range, Megha, very good. Range is 25. Ustad, yes, Bibika, Himanshu, Bhargavi. Yes, Bhargavi, yes, 25 kgs will be the correct answer. Yes, Divya, Jyoti. Now, can you tell me? Yes. Zeba, yes. Bibu. Imanshu saying 20.16 is the correct answer. Ustad is also saying that. 25 upon 124. Okay, into 100. This is 20.16. Yeah. Okay. So, 25 divided by 124. Yeah, very good. Excellent. So, we have now understood what is range, what is coefficient of range. Okay. Now, let us use this, the property. So, first we understood what is range. Range is largest minus smallest. Then we have obtained coefficient of range, which is the relative measure of dispersion. And now we are talking about the properties. If the relation between x and y is given by this and the range of x is this, what would be the range of y? Now, what have they given us? They have given us 2x plus 3y is equal to 10. How should my equation look like? It should look like y is equal to a plus bx. I'll keep y to the left hand side and keep all the others to the right hand side. So 3y is equal to 10 minus 2x. Okay. So y is equal to 10 upon 3 minus 2 upon 3x. Okay. So this means a is equal to how much? 10 upon 3. B is equal to how much? Minus 2 upon 3. Now, what is the property saying? The property says that it is unaffected by change of origin, but it is affected by change of scale. Okay. So, we say that R of y is equal to mod of b into R of x. Okay. So, the new range will be equal to mod of b into R of x. Now, what is b? B will be mod of minus 2 by 3. And what is range of x? Range of x is given to me as 15. So, into 15. What does mod mean? Means that you don't have to consider the sign minus or plus. You have to take it only as plus. So, this is equal to 2 upon 3 into 15. So, 3 ones are, 3 fives are, which is equal to 10. Ry is equal to 10. Okay. So, this is the answer. Has everybody got this? Yes, Kamini, Zeba, right? Liza, Sagar, Masum. Faizan, very good. Yes. Swati also, Bhargavi, Atharva, Vanshika. Yeah. So, I hope you've understood this. Clear? Okay, Jyoti, you want this to be repeated? Okay, let me do that. What happens here is that when I have for data, I have a set of data. I found its range. I found its coefficient of range. And then I came to know that I want to see, like in experiments, you want to know what will happen if the data is expanded. What will happen when the data is contracted? Okay. So for that, what we do is we will change the origin or change the scale or do both. Okay. You can do one, you can do both, or you can do one of them. Okay. So I have a set of data. Okay, I had a set of data and its range. Okay, its range was 15. Okay, I have a set of data whose range is 15. But then I want to change. Okay, so I change its scale so that each observation was multiplied by a number. And then I also wanted to change the origin. So how did it happen? So it is given by this equation. Now whenever I want to use the formula for range is, which is Ry is equal to mod of b into Rx. Okay. I have this formula. I can use this formula only when my y is equal to a plus bx form. My equation should be written as y to the left hand side and x to the right hand side. So how do I do that? So I take this equation. My equation is 2x plus 3y is equal to 10. I keep y to the left hand side and this 2x I take it to the other side. Okay. So it will become 3y is equal to 10. When I move across the equal to sign, the plus will become minus. So this becomes plus 2x will become minus 2x. Now, again I wanted only y. I don't want the equation in 3y. I want it only in y. So what I do is I write it y is equal to, so I dividing both sides. Okay, for those who don't know, dividing there, I write that in red so that you remember also. Dividing both sides by 3. Okay. Then what will happen is 3y upon 3 is equal to 10 minus 2x upon 3. So this will become y is equal to, now I don't want it in this way. I want a plus bx form. So this is 10 upon 3 and minus 2 upon 3x. Okay, now this equation is in the form y is equal to a plus bx. Now what will happen? How much is my y? How much is my a? Is 10 upon 3. And how much is my b? It is minus 2 upon 3. And so I use this. Okay, so ry will be equal to mod of minus 2 upon 3 into rx. Rx is 15, that is given to me. Okay, here rx is 15. So this becomes 2 upon 3 into 15. 3 ones are 3 fives are 2 fives are 10. Okay, so ry is 10. Okay, Jyoti, I hope you've understood. Second point you've understood now, Arshdeep? Yes, Sonali, Avinash. Sure, change of origin means if you know the graph system, okay. So this is my graph. Now suppose this is my origin. I want to change that. It becomes this, and over here each point is 1, 2, 3, and then I change this to 1, this to 1.5, 1.5. Okay, so I change the origin and the scale also I change to 4, 6. Okay, that type. So you didn't even go into all those details. What you need to remember here is that when that happens, rearrange the equation in the form y is equal to a plus bx form, and then you have to solve it. Okay. So these sums can be done quickly provided you know the property that range is unaffected by change of origin and is affected by change of scale. Now we will go to mean deviation. Yes, Akaldeep, don't go into so much of detail right now. We can have it later on. Or you can, like in one of the last videos, I will explain that. Okay. Yes. Yes, Jyoti. Good. You understood, Bhargavi, Swati, Liza, Ashdeep. Yeah. Okay. Now mean deviation. So what did range tell you? Range gave you an overall idea. Okay. When I said that, see, the range is 60 marks. That is the highest student in accounts has got 100 marks and the student who has got the lowest marks is 40. But that is only about 2 students, right? The highest and the lowest. Now what happens about the overall picture? How do I measure or how do I understand what is the deviation from the mean? Okay, so that is why we have mean deviation from the mean and mean deviation from the median. Why? Because these are central tendencies. So this is a value around which most of the data is revolving. So first we are going to talk about mean deviation. So first is mean deviation is a measure of dispersion which is known as average deviation, because mean is average. Okay, mean deviation can be computed from the mean as well as median. Mean deviation is the arithmetic deviation of different items from the central tendency. Okay, so we know the measure of central tendency, arithmetic mean, median, okay, mode. So those we have already studied. So finding the mean deviation from that will give me mean deviation. So from the median or from the mean, it is going to look like this. So mean deviation from mean will be summation of x minus x bar. That is, I first find out x bar, that is the mean, and I take deviations of each of the observation from the x bar, and then I sum them up and divide it by n. What is n? N is the total number of frequency, that is summation f, or you can write it as n. Now mean deviation from median is similar, very similar. Only thing here, in first you calculated the mean, now you have to calculate the median. It is the same. I find the sum of all the deviation x from m upon n. Okay. So x minus m upon n. So median upon n. So for what do you do when the data is given to you? First find the median, then find the differences of each of the observation from the median, add them up, and then because it is modulus, so that means you have to take only the positive values and then add them up and divide it by n or summation f, that is the frequency. Now that is for discrete variables. Now what happens when I have group data? For a group data, the frequency distribution can be given as this. Or whenever, even for discrete data, whenever frequency is given to you, what is that? Mean deviation about the mean will be equal to 1 upon n summation of x minus x bar into f. So in the earlier place, we have just found x minus x bar. Now here we find the difference, and then we multiply it with the frequency of that class or that variable or that observation, and then we add the multiplication, or we add all these multiplications and we add them up. That is my summation x minus x bar into f, and then I divided by n, or the summation f. Now then what will happen? What will be the relative measure of dispersion in this case? The coefficient of mean deviation. So this is mean deviation, and then coefficient of mean deviation will be equal to mean deviation about the mean upon the mean into 100. Okay. And if you are calculating coefficient of mean deviation about the median, it will be mean deviation about the median upon the median into 100. Okay. So depending on you are finding the mean deviation around which measure of central tendency, mean, median, or mode. Okay. So first we talked about, see here we talked about mean deviation from median and mean deviation from mean for discrete variables. Here we are talking about mean deviation of discrete variables but with having frequency. Then we are also, and this formula also applies for frequency distribution. Then coefficient of mean deviation will be mean deviation upon x bar into 100. Okay, and what is mean deviation? X minus x bar into f upon n. So coefficient of mean deviation about the median will be mean deviation about the median upon mean deviation upon median into 100. Now again the property, very important. Okay, what is the first property say? Mean deviation takes its minimum value when the deviations are taken from the median. So this is a theory question. Mean deviation takes its minimum value when the deviations are taken from the median. You do not have to go into how that happens or the theorem or prove that. We don't need to. You just need to know this property. Also, second property is that mean deviation remains unchanged due to change of origin. But third property is it changes in the same ratio due to change in scale. Okay. So like we did for range, same thing, y is equal to a plus bx. Then mean deviation of y will be equal to mod b into mean deviation of x. Okay. So this is for group data. That this is for mean deviation. First important property is mean deviation takes the minimum value when the deviations are taken from the median. Second property is mean deviation is unaffected by change of origin. Third property is mean deviation changes with change of scale. Okay, coefficient of mean deviation is mean deviation about median upon median, which we have already written over here. So if A assumes a value, so that is the discrete values x1, x2, then we say mean deviation is given by 1 upon n summation x minus a. For group frequency, we have mean deviation as 1 upon n summation x minus a into f. So don't forget to multiply by the frequency. Otherwise, we are so in a hurry. We just take the deviations and we add them. That is okay when I have discrete variable. That is okay when I have discrete variable. But when I have a group frequency distribution, this f is very important. Okay, this f, don't forget. Sometimes even I forget. So we should not forget this f. And n is what? N is summation f. Okay. Okay till now. Yes, understood. Very good. Okay, Simon, we'll take it up later. Let me see whether I have already taken this question. If not, then also we'll do it. You're not able to see, Sagar? Okay. Now you can see? Yes, Char? Very good. So now we are talking about relative measures of dispersion applying the mean deviation. So coefficient we have already told. Then we have already said this. Okay. Okay. So first important property is that it takes its minimum value when it is taken from the median. Second important property is remains unchanged due to change of origin. But third property is that it changes in the same ratio due to change in scale. So we are taking this example 14.2.4. Okay. So can you tell me the mean of this? Okay. What is the formula? X bar is equal to summation x upon n. Now what is summation x? It will be 5 plus 8 plus 10 plus 10 plus 12 plus 9 upon. How many are there? 1, 2, 3, 4, 5, 6. Okay. When you have such small numbers, try to do it directly on the calculator. Don't spend time while in writing because this is only simple. I'm just writing it here for you, for your understanding. Just make sure you're counting correctly. 1, 2, 3, 4, 5, 6. Okay. Now can you tell me this? Yes, Agar, you can see. Is it 9 or is it 6? Bibhu and Himanshu, you, Harshita, you've got different answers. Shalini also. Nital, why are you writing 10 upon 6? What is the total? Yes, Samir, it's 9. Okay. Yes, very good. So everybody has got 9 as the answer. Okay. Let me check. 14 plus 20, 34. 13 plus 20, 33 plus 12 plus 9 divided by 6. Okay, yes. So we have got 9 as. Now what we will do, we will write the numbers. So we'll write the numbers 5, 8, 10, 10, 12 and 9. Now I will find out x minus x bar. Now how much will this be? From every number I will subtract 9 and I use this. So what is 5 minus 9? So this is 5 minus 9, which is equal to 4. 8 minus 9 equal to 1. 10 minus 9 equal to 1. 10 minus 9 equal to 1. 12 minus 9 equal to 3 and 9 minus 9 equal to 0. Okay. So now can I find out this addition? This is summation x minus x bar will be how much? Just add them up. 4 plus 1 plus 1 plus 1 plus 3. So 10. Okay. So what will be my mean deviation about the mean? Will be equal to summation x minus x bar upon n. So how much is this? 10 upon 6. So, okay, so you were giving me directly the answer. Okay, 1.67. Okay, yes, everybody, are you there on the right page? Excellent, Lakshita. Yes, Arshdeep, you don't have to bother about the minus sign. No, that is the whole thing. We just want to have understand what is the deviation from the mean. We don't want to know whether it is a plus deviation or a minus deviation. Okay. Suppose, see, this is my mean. Okay, this is my x bar over here. Some numbers here will be x1, this will be x2. Okay. I want to know what this distance is. Okay. I just want to know that this value x2, how far is it from x? I don't want to know whether it is greater than or less than. Okay. That is why we are using the mod. x1 here is less than x bar. x2 is more than x bar. But what that means is that from the mean, they are at different distances. So I just want to know the difference. I don't want to know how much, whether it is more or less. Okay. I just want to know the magnitude of that difference. Okay. Now, what is the mean? What is the value of mean deviation about mean for the following numbers? Okay. So what will be the step 1? Calculate mean. Step 2 will be calculate x minus x bar. Third step, add the deviations. And fourth step will be put the formula, put it in formula. Okay. So I have, what are the numbers? X. Then I have mod of x minus x bar. Okay. Now numbers are 5, 8, 6, 3, 4. What is the first step? First step is find summation x. find summation x. Summation x is how much? And then we have x bar is equal to summation x upon n. Now, how much is my n here? 1, 2, 3, 4, 5. So, n is 5. And I've got the formula now. So, how much is my x? 5 plus 8 plus 6 plus 3 plus 4. That is 26. So, this will be equal to 26 upon 5, which is equal to 5.2. Is my answer correct? You only let me know. 26 exactly 5.2. Yes, Nitar. Yes, Divya. Yeah, Zeba. Ustad. Okay, so now what I'm going to do, I'm going to write here for the first, I'm going to write 5 minus 5.2, which is equal to how much? 0.2. 8 minus 5.2. This is equal to how much? 2.8. Then 6 minus 5.2, which is equal to 0.8. Then 3 minus 5.2, which is equal to 2.2. And 4 minus 5.2, which is equal to 1.2. Now, can I have summation x minus x bar from you? Can I have that value? This is 3. This is 6, 7.2. Yes, Raghav, very good. 7.2. Now, I will put it in the formula. I know the formula. What is the mean deviation about mean? Mean deviation about mean is equal to 1 upon n summation x minus x bar. Okay. So, how much is this? How many figures are there? N is 5. So, 1 upon 5. What is the summation x minus x bar? It is 7.2. So, how much is 7.2 divided by 5? It will be 1.64. Oh, 1.44. Right. 1.44. Yes, Harshita, Tejashri. Yes, Raghav. Vishnu, yes, correct. Megha, yeah, yes, Megha. This will be the correct answer. So C will be the correct answer. Correct. Pratidna, yes, correct. Okay. So we have talked about mean deviation about the mean. Now let us find out mean deviation about the median. Okay. Same thing. Same thing is what are the steps? Find median. For that, whenever we have median, always remember first arrange, then find. Okay. So what is the first step? Rearrange in ascending or descending order. Okay. Second point is find midpoint, middle value. Okay. Find middle value. That will be your median. Second is what? Find deviations. Okay. Find deviations. What are the deviations? X minus M. Okay. This median is M and we are finding the absolute difference and then find the formula. Add them. Add these deviations and fourth will be put it in the formula. Okay, so first step is we have to find rearrange them. Okay, so I will first find the smallest number. Smallest number is 52. 52. Then we have 56, 70, 75. No, 7, not 70, 68. Then we have 68, then 70, then 75, then 80, and then 82. How many numbers are there? 1, 2, 3, 4, 5, 6, 7. So how do I find the median? Median will be the middlemost number. So what is the middlemost number? 1, 2, 3, 4. So this will be my middlemost number. So that there are 3 numbers below it and 3 numbers above it. So I have arranged it in the ascending order. Okay, so this is my median. Okay, so now whatever I do, a simple thing as we did earlier also. What are the values of x? 52, 56, 68, 70, 75, 80, and 82. Now I have to find what? The absolute value of x minus minus median. Median is how much? X minus 70. So can I do that? So this will be 52 minus 70. 18. Then 56 minus 70. 14. Then 68 minus 70. 2. Then 0. Then 5. Then 10. And then 12. Okay. Important thing now is finding summation x minus summation mod of x minus m is equal to how much? Okay. So that value also I can find out. That is 18 plus 14 plus this plus 10 plus 12. 61. So that is 22 plus 7 plus 32. 61. Okay. So what will be mean deviation? Mean deviation about the median will be equal to 1 upon n summation x minus mean. Okay, so what is the value I have got? What? How many numbers are there? 7. 1 upon 7 x minus x bar is 61. So 61 divided by 7, answer will be 8.71. I hope I've calculated correctly. 61, 8.7. Yes, Bibika, Soumya, Zepa, Manchika, Bhargavi. Okay, so now this is in thousands. Abhi now see here they have given the following profits of this. So this is very important profits. So that see in the option they may give you this 8.71 or they may give you as 87112. Okay, 3. So this will be your deviation. So because the data that was given is already in thousands. Okay, so what is the profit of the firm during the 1 week? It is here it is 82,000, then 56,000, then this. So this is into 1,000. 8.71 into 1,000. So that is 870. Okay, yes, and coefficient of so for coefficient, what is the formula? It is mean deviation up median upon the median into 100. How much is the mean deviation? 8.71. How much is the mean median? It was 70 into 100. So how much is this? (52 minus 70). उस्ताद वही तो बोल रहे हैं ना बार बार कि आपको mod लेना. You have to take the absolute value. You don't have to consider it as minus or plus sign. Okay, just take what is the difference. 8.71 divided by 70. So this is 12.45. 12.44. Right? Yes, thank you for pointing it out because we are talking in thousands. 8.71 into profits is in thousands. So into thousands will give you rupees 8710. Okay, yes, correct. Sagar, very good. Bhairavi, yes. Okay, so here we have got Asha Babu. Next question we are going to do is for the properties. If the relation between x and y is this and the mean deviation about mean for x is 12, then the mean deviation of y about mean. So we know the property. I have also written it over here. Here mean deviation remains unchanged due to change of origin, but changes due to change of scale. Okay. So here, as we did for range, what you have to do first step is rearrange the equation in the form y is equal to a plus bx. Okay. What is the equation? We have got 5y minus 3x is equal to 10. How should the equation look like? It should look like y is equal to a plus bx. Then what will happen? Ry will be equal to mod of b into Rx. What is mod b? It means you are going to take only positive values. So this is how much? 5y is equal to minus 3x. I take to this side, it becomes plus 3x. So 10 plus 3x. So y is equal to how much? 10 upon 5 plus 3 upon 5 into x. So this is same as y is equal to a plus bx. Okay. So my a is equal to 10 upon 5 and my b is equal to 3 upon 5. Okay. So my ry, which is equal to mod b into rx, okay, becomes b is how much? 3 upon 5. Rx is how much? 12. So this is 36 upon 5. So this is equal to 7.2. So answer will be A, 7.2. That's very good. Vaishnav, Himanshu, Avdesh, Bibika. Yes, Ashbabu, Shalini, Fezan, Nittal and Lakshita. Yeah. So next we are going to do mean deviation about mode. Okay. Now here you have to just pay attention to the numbers. These are all numbers 4 upon 11, 6 upon 11. Four upon 11, 6 upon 11, then 8 upon 11, 9 upon 11, 12 upon 11, and 8 upon 11. How many numbers are there? 1, 2, 3, 4, 5, 6. There are 6 numbers. 1, 2, 3, 4, 5, 6. Now, you can use it this way also, or you can right now just consider for this 4, 6, 8, 9, 12, 8. Okay. We are just considering the numerator because I can see all the denominators are same. So this is just for my understanding. So what happens? Which is a number that is repeated most? Which is the number that is repeated most? 4 is repeated once, 6 is once, 8 is 2 times. Okay, so mode will be 8. Okay, last time we have done that. Mode is the number whose is the observation who has the maximum frequency. So here mode is 8. Now I want to find mean deviation about the mode. So I will take the numbers. Okay. So this will be x and this will be x minus absolute value of x minus 8 upon 11. Okay. Now we will take the whole number. We just wanted to be easily understood. Or here also you could have done, even here also you can see that 8 upon 11 is repeated 2 times. Now what are the numbers? 4 upon 11, 6 upon 11, 8 upon 11, 9 upon 11, 12 upon 11 and 8 upon 11. Now what do I have to find? I want to find the difference. So this is 4 upon 11 minus 8 upon 11, which gives you 4 upon 11. Because I am taking the absolute value, I don't consider it the sign. 6 upon 11 minus 8 upon 11 gives me the value 2 upon 11. 8 upon 11 minus 8 upon 11 gives me 0. Then 9 upon 11 minus 8 upon 11 gives me 1 upon 11. 12 upon 11 minus 8 upon 11 gives me 4 upon 11. 8 upon 11 minus 8 upon 11 gives me 0. Now I have to do what? I have to find the summation. What do I have to do? I have to find the summation. So summation x minus mod will be equal to how much? Absolute value of that. So 4 plus 2 plus 1 plus 4. That is 11 upon 11, which is equal to 1. 4, 5, 6, 7. So x minus mod is equal to 1. So mean deviation about mode for the numbers is 1 upon 11. Okay. So because what is the formula? What is the formula? Mean deviation about the mode will be equal to 1 upon n into summation x minus mod. Now how much is n? 1, 2, 3, 4, 5, 6. Okay. So 6, 1 upon 6 into how much is this? 1. So answer is 1 upon 6. So A will be the correct answer. Yes, thank you, Sagar. You like the teaching? Good. Yes, Avdesh, A will be the correct. Vaishnavi, yes, 1 upon 6. Rohini, yes, 11 upon 11, you're getting 1. And Bibika, correct. Divya, you've got that 1 correct. And you just have to, don't forget to do this next step. Okay, this is very important. Otherwise, we will feel कि okay, मैंने difference निकाल दिया. So that is not enough. You have to also put it in the formula mean deviation against of the mode. Now, the second deviation we are going to talk about is the quartile deviation. Okay, quartile deviation is a measure of dispersion. In this method, the difference between the upper quartile and the lower quartile is taken and called as the interquartile range. So, QD is written as Q3 minus Q1 upon 2. Now, in the last lecture, we talked about quartiles, deciles, percentiles. So, same concept we are using over here. So, we find the Q3 and Q1. So, I have a set of data, and when I want to divide it into 4 equal parts, I find Q1, Q2, Q3. So, those are the quartiles. In that, Q2 is also known as the median. Okay, so Q2 coincides with the median. Okay, because Q1, Q2, Q3 are all positional measures, and you know that median is also a positional measure. Okay. Then we have coefficient of quartile division as Q3 minus Q1 upon Q3 plus Q1 into 100. Okay. What are the properties of quartile division? Quartile division provides best measure for open-ended classification. Why it? How it does that is because when we are considering, we are not considering the lower values and we are not considering the upper values. So we are considering only Q1 to Q3. So therefore, whenever, suppose we have that we have the class interval as it starts 200, then we have 200 to 300, okay, and then we have 400, 300 to 400, okay. So here I don't know whether it is from 0 to 200 or it can be from 100 to 200, where this information is not given. It is just saying dash 200. Then we say it is an open-ended classification, okay. Then quartile deviation is less affected by sampling fluctuation, okay. These are important points for theory. Then quartile deviation is unaffected by change of origin, and quartile deviation is affected in the same ratio due to change of scale, okay. So this is a different one. It is less affected by sampling fluctuation, and this we are already doing for range. We have also done it for mean deviation, and here also we are saying qy is equal to b into qx, okay. So these are the properties. First property is saying that it is provides the best measure for open-ended classification. Second, it is saying it is less affected by sampling fluctuation. Third, it is unaffected by change of origin. And fourth is it is affected by change of scale. So Qy will be equal to modulus of B, that is the absolute value of B into Q of X. That is quartile deviation of X. Okay. So before we jump into the next question, so let us take a small break. I'll be back in 2 minutes. Okay, so let us take a break of 5 minutes. Vinu? Yes, okay. Welcome back. We are discussing quartile division. So in quartile division, we take the data, we arrange it in the ascending or the descending order. Then we divide it into 4 equal parts. So the Q1 will represent 25%, Q2 will represent 50%, and Q3 will represent 75% of the data. Now what happens here is that because this is a positional measure, it coincides, Q2 coincides with the median also. Okay, and this is also useful for open-ended distributions. Then it is also that it is less affected by sampling fluctuations. Then it is unaffected by change of origin, but is affected by change of scale. Okay, so let us do 14.2.8. Okay, Saima, you are asking about this. So I think you have not attended last time's lecture where I have taught you how to find Q1, Q2 and Q1, Q3. So never mind, whenever you have discrete data, there is a particular method of doing it, and whenever you have group frequency distribution, then we will be doing in another method. So since this is already given to us, let us first find this. The first step is rearranging the data in the ascending or the descending order. I am arranging them in the ascending order. So which is the smallest number? Smallest number is 42. Then we have 48. No, for smallest is 35. Okay. So smallest is 35. Then 42. Okay, 35, 42, 48. Then 50, then 55, 50, 55, 56, 60, then 65, 75, and 82. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's always a good thing to first find out how many numbers are there, and then we are able to do that. Okay. So these are the numbers. I have arranged them in the ascending order. Now I must find Q1 and Q3. Okay. Now Q1. How do I find Q1? To find Q1, I must use n plus 1 upon 4 into 1th term. Okay. And for Q3, I must find n plus 1 upon 4 into 3. Third term. Okay. Now how much for Q1, what is the number I get? There are 10 numbers. So this is 10 plus 1 upon 4 into 1. So this is 11 upon 4, which is equal to 2.75. Okay. 8, 9, 10, 11, 30. Yes. And for Q3, what do I get? It is 11 plus 11 into 3. This is, it is 11 into 3 upon 4. So that is 33 upon 4, which is equal to 8.25. Okay. 8.25 into 4, 33. 2.75 into 4, 11. Okay. So now where will Q1 be? It will be after the second term, and it will be equal to second term plus the 0.75 of the difference between the third and the second term. Okay, so Q1 will be equal to second term plus 0.75. Okay, this 75 is then 0.75 into third term minus second term. Okay, so second term is how much? 1, 2. This is my second term. This is my second term and this is my third term. Okay. So second term is 42 plus 0.75 into 48 minus 42. Can you calculate and tell me how much this is? Q1, what is the value of Q1? Yes, can you do that? Yes, Bhargavi, yes, 35. Bibika, let us do this sum right now. Okay. Arshita, it is 46.5. Arshita saying 46.5. Others, please confirm. Yes, because the Q1 is lying after the second term, but before the third term. Okay. Harshit, Nital, oh, Sagar. Okay. So that is why we take it between the second and the third term because it is 2.75. The value is somewhere after the second term, but before the third term. So it is 2.75. It is neither 3 nor 2. Okay. It's a positional measure. Yes, 46.5. Yes. So similarly, can Himanshu is already calculated, but for the others, can you calculate Q3? Yes, Chahal, the whole question paper is 100 marks MCQ. Now Q3 is what? 8.25. So it will be 8th term plus 0.25 into 9th term. What is after 8? 9. So 9th term minus 8th term. So what is the 8th term? Let us see 8th and 9th term. Let me mark that. 1, 2, 3, 4, 5, 6, 7, 8. 8 and 9th term. Okay, so that is going to give me 8th term is 65 plus 0.25 into 75 minus 65. That is 2.5. So this is 67.5. Okay. So from this, I have got Q1, I have got Q3. Okay. From this, I have got Q1 and I have got Q3. Now I can find quartile deviation. Quartile deviation will be Q3 minus Q1 upon 2. So which is 67.5 minus 46.5 upon 2. How much is this? And what will be the coefficient of quartile deviation? Will be Q3 minus Q1 upon Q3 plus Q1 into 100. Okay, so can I find quartile deviation? What will this value be? 18.42? 10.5? This is 10.5 and then coefficient is how much? Can you find out coefficient? 67.5 minus 46.5, it is 21 divided by 2 is 10.5. Okay. Then I have Q3 67.5 plus 46.5, 114. 21 divided by 114, 18.42. Yes, very good, Vibhika. It is 18.42%. Yes, Ash Babu, Shalini. Yeah, very good. Okay, so this is how we have to calculate the quartile deviation. So first find out Q1 and Q3. But very important here is, okay, please remember that we need to rearrange. Okay, rearrange the numbers. Otherwise, everything will go wrong. Okay, first rearrange and then you find the solution. Now we are using the property. We are using the property which says that quartile deviation of y is equal to mod b into quartile deviation of x. And when will that hold? When y is equal to a plus bx form. When your equation is in y is equal to a plus bx form. Now what is the equation given to us as 3x plus 6y is equal to 20. So I keep y on the left hand side, take x on the right hand side. So 3x will go over here. So 6y is equal to 20 minus 3x. So y is equal to 20 upon 6 minus 3 upon 6 into x. And what do we need? Is equal to y is equal to a plus bx. So I get here as a is equal to this and b is equal to minus 3 upon 6. So b is equal to minus 3 upon 6, which is equal to half. So we have q dy to be equal to mod of b into qx. This answer I'm going to get as b is equal to 1/2. Okay, because we are taking only the positive values. So 1/2 and quartile division of x is 6. So quartile division of y is 3. So 3 is equal to qy. Okay, everybody understood this? Sakshi, how did you get 12? Yes, okay. Saima, I hope you've understood this. Now here they are asking, so in this question, they are already asking you, what measure of dispersion you will use. Now, and up till now we have taken sums where which measure of dispersion I have to find out. I already knew. Here they are asking you that you decide which measure of dispersion you have to find and then find it. So here see, like I was telling you, up to 20. When this is there, it is an open-ended classification. And when you have open-ended classification, you should use quartile deviation. So since this is an open-ended classification, appropriate measure will be quartile deviation. So you will find QD as the quartile deviation does not take into account the first 25% and the last 25% of the observation. So reason you don't have to do, remember, only whenever you see an open-ended classification, you must use quartile deviation. Okay. So can we do this sum? So how do I find Q1, Q3 for this? Now first find n. What is the value of n? N is summation f. How much is that? 5 plus 11 plus 14 plus 7 plus 3. So which is 40. Okay. So for Q1, I will have n by 4, which is equal to 10. For Q3, I will have 3n by 4, which is equal to 30. So what do? I find the less than cumulative frequency and I find out the measure of dispersion. Okay, so I just write down A because I don't know the class boundary. The second class boundary will be 20. Okay, also remember here, while you are doing this sum, just check. So here this is 20 and here this is also 20. Then this is 40, this is also 40. So this is a continuous distribution. This is a continuous distribution. So I don't have to use 0.5 etc. over because they are already continuous. So I don't have to make the frequency distribution continuous. So therefore I am using this A, then 20, 40, 60, 80 and 100. This is my class boundaries. This is my class boundary. Then I find out what are the frequency. Less than 20, the frequency, okay. What are the frequencies? First I write down and then I will write down the cumulative frequencies. So how much do I have? 5, 11, 14, 7 and 3. Okay, so what is happening here? This is 0, this is 5, this is 16, this is 30, this is 37 and this is 40. Okay. Now for Q1, Q1 it is 10. So where will 10 lie? 10 will lie over here. Okay, 10 will lie over here. So what is the formula for Q1? It will be equal to N by L1 plus N by 4 minus NL upon NU minus NL into C, where C is the class width. What is the class width or class length? It is 20 over here. So I can find out Q1. Q1 is the lower class boundary of the quartile class. So what is the lower class boundary here? 20. So this is 20 plus N by 4 is 10 minus L. This is NL. So that is 5. NU is how much? Post quartile class, that is 16 minus 5 into 20. Okay, so can you find this for me? So 5 divided by 9 into 20 plus 20, 31.11. And similarly Q3 will be, for Q3 it is 30. For Q3 I have to find where 30 is going to lie. So 30 I have already have 30. Okay, Q3 in this sum they have already done this for you, that Q3 is over here. Okay, for Q3 3n by 4 is already here. So what will be? It will be 60. Okay, it will be, Q3 will be 60. Because I don't have to put it in all this formula because already I'm getting this 30. So Q3 is 60. So what do I have now? I have to find out Q3 minus Q1 upon 2 and I have to find the answer. (16 minus 5, 9). Or 16, 11, sorry. This figure is 29.11. 29.11. 0.01. Okay, so this is 5 divided by 11 into 20 plus 20, 29.09. Okay, so can you find out Q3 minus Q1? So this is equal to quartile deviation will be 60 minus 29.09 upon 2 minus 60 upon 2 is 15.45, and coefficient of quartile deviation will be equal to 15.45 upon 60 plus 29.09 into 100. Okay. So that is 60 plus 29.09. Okay, 89.09. So this divided by 89.09 is this much into 100. So 17.35. Okay. Can I get some answers from you? 15.4, so yes, Ash Babu. Himanshu, yes. 29.09. This is 15.46. Yes, Lakshita, Rohini, Vaishnav, Bhargavi. Okay. Bibika and Rohini. Yes, Bharat. Ardhendu. Okay, so here what we have to do is, if you did not follow how to calculate Q1 and Q3, just see my video of the last lecture. Okay, so there we have done sums on how to calculate Q1, Q3, that is quartiles for the group frequency distribution. Okay, so from there you will be able to practice sums on quartile deviation. So do that after you know how to calculate Q1, Q3. Then what you have to do is you have to find quartile deviation, which is Q3 minus Q1 upon 2. And you have to find coefficient of quartile deviation, that is Q3 minus Q1 upon Q3 plus Q1 into 100. Okay. Then coming to important thing, that is standard deviation. It is the most used measure of dispersion, that is standard deviations. For discrete data, it is given by, so sometimes you will have the symbol this, you may have the symbol this. Okay. So this is equal to square root of summation of x minus x bar the whole square. So in earlier sums we have calculated the deviation from the mean. So you find the deviation from the mean, then you square it. Okay, you find the deviation from the mean and you square it, and then you find the total of that. Then when this is divided by n or summation f, this is your standard deviation, which is also written as under root of summation x square upon n minus x bar square. Okay, minus x bar square. That is, I find the numbers, I find the squares and I add them up divided by n, and then I find the mean. I subtract that, I square the mean also, and then I take the square root side. Then I take their square root. For the group frequency, group data, you will only have to multiply this difference by f. Okay, so this f is very important here, that you multiply by f. So you can even write this as standard deviation for a group data is equal to square root of summation fx upon n minus x bar square. Okay. So you take the numbers fx square, sorry, fx square. So you take the numbers, square it, multiply it by its frequency, add them up, divide it by n, and then from that you subtract the mean square. Then there is a concept. This is standard deviation. Then there is the concept of variance. Variance is simply S square. Whatever your standard deviation you found out, when you square it, it is known as variance. So for group data, what happens is it's simply that the square root sign goes away. When you find variance, you don't need to find the square root. So S square is summation x minus x bar whole square upon n, which is also equal to summation x square upon n minus x bar square. Okay, for unclassified data, and for group data it is x minus x bar whole square upon n. Then coefficient of variation, this is also, you get a lot of sum on this formula. Coefficient of variation is standard deviation upon arithmetic mean into 100. So this coefficient of variation, COV, is very important, or you can also call it as CV, which is nothing but the standard deviation which you have calculated from any of this formula above upon mean that you already have calculated when you're calculating the standard deviation into 100. Okay, so this is how you are supposed to do it. Okay, these are the formula, and now we go to the sum. So variance is another measure of dispersion. The term variance was first used in 1918 by R.A. Fisher. Variance is known as the square of the standard deviation. Okay. Okay, and this is also one important formula. Standard deviation of n natural numbers can be found out using the formula. So sigma is equal to square root of 1 upon 12 n square minus 1. Okay. The sum of square deviations taken by the arithmetical mean is minimal. Okay, the sum. This is also an important property that you need to know. Okay. So standard deviation of n natural numbers can be found out by sigma is equal to square root of 1 upon 12 n square minus 1. And second is the sum of square deviations taken by the arithmetical mean is minimal. Okay, this is a theory question. And this is an empirical formula. Now we know of standard deviation, we know of mean deviation, and we know of quartile deviation. So this, using this empirical formula also, sometimes you may be asked question. Okay, 6 QD is equal to 5 MD is equal to 4 SD. So you remember QMS in geometry, when we are solving problems, we use QMS. So then we have Q, M and S. So 6 times quartile deviation is equal to 5 times mean deviation is equal to 4 times standard deviation. Okay. So these are the two properties that we are going to use, on which we will get sums. The other properties of standard deviations are same. If all the observations of constant are constant k, then the standard deviation is 0. Okay. If all the data are constant, then the standard deviation is 0. So suppose 5, 5, 5 are my 3 observations, then what will be the mean? Mean will be 5. What will be the deviations? Deviations will be 0. Okay, because there is no deviation. All the numbers are the same. So therefore, if all the observations are constant k, then the standard deviation is 0. Important theory question. Standard deviation remains unaffected by change of origin, and it is affected by change of scale. So if you have y is equal to a plus bx, y is equal to a plus bx, then the standard deviation of y will be equal to mod b standard deviation of x. Now this is also an important formula next, on which you will get you may get a sum, is if there are two groups. Like you remember when we talked about combined mean? In combined mean, what we talked, like if there is a group of data with n1 observations and it has x1 bar as its mean, and if we have another set of observations with having number n2 and having its mean as x2 bar, then when we combine these two groups of data, then we get x bar is equal to n1 x1 bar plus n2 x2 bar upon n1 plus n2. So that was the formula for combined mean. So similar formula, a little more complicated than that one, but we have a similar formula for quartile for standard deviation also. So suppose I have a set of data with n1 as its number of observation, x1 bar as its standard arithmetic mean, and s1 as its standard deviation, and another group of data with n2 as its number of observation and x2 bar as its mean and s2 as its standard deviation. Then when I am combining these two groups, then I get this as d1 is x1 bar minus x bar, and d2 is x2 bar minus x bar. Okay, so what I must find first in this case, when I want to find the combined standard deviation, first find x bar, then find d, then find so individual x, then you find the combined mean. Okay, so find the combined mean, then you find the deviations d1 and d2. Okay, and then you find the combined standard deviation. What does the formula say? It says that s is equal to under root of n1 s1 square. That is, n1 is the number of observations of the first group, and s1 is the standard deviation of the first group, that square, plus n2 s2 square. Then you have n1 d1 square plus n2 d2 square upon n1 plus n2. N1 plus n2. This whole thing is under the square root sign, where you have this x1 minus x bar. So what is x bar? It is the formula for combined mean, which is equal to n1 x1 bar plus n2 x2 bar upon n1 plus n2. Okay. So these are the other properties of standard deviations. I'll just repeat them. The standard deviation of n natural numbers taken can be found using sigma or the same. Okay, s is equal to or sigma. So it is just a symbol. S is equal to sigma is equal to square root of 1 upon 12 n square minus 1. That is first. Second is the sum of squares of deviation taken from the arithmetic mean is minimum. Third, the empirical relation is 6 times QD is equal to 4 times MD is equal to 5 times MD is equal to 4 times AD SD. Okay. So 6 times quartile deviation is equal to 5 times the mean deviation is equal to 4 times the standard deviation. The other properties are, if all the observations are constant, then the standard deviation is 0. Second is, it is unaffected by change of origin. Third is, it is affected by change of scale, that is sy is equal to mod b into sx. And the combined standard deviation is given by n1 s1 square plus n2 s2 square plus n1 d1 square plus n2 d2 square, the whole thing upon n1 plus n2, and for the whole thing you will find the square root. Okay, are these formulas clear to you? And if they are, we will find this. Okay. What is the formula for standard deviation? Saying that it is square root of sigma x square upon n minus x bar square. Okay, so let us find them. First, I will write x, then I will write x square. So this is 5, 8, 9, 2, 6. First step is I find the summation x. How much is this? 13 plus 11 plus 6, 30. Okay. How many numbers are there? 1, 2, 3, 4, 5. So what will be my x bar? X bar will be 30 upon 5, which is equal to 6. So first step I have done, I found x bar. Now I need to find summation x square. Now what is the square? 5 square 25, 8 square 64, 81, 4 and 36. So can I find this? 25, 64, 81, 4 and 36. 210. Okay. I just check 25, 64, 81, 4 plus 36, 210. Now I will substitute here. I have got all the values. What are the values I need for standard deviation? This is summation x square. Then I need then I need n, and I need standard and I need mean. Okay, x bar. So sigma, which is equal to square root of summation x square upon n minus x bar square. So this is equal to square root of x square is 210 upon 5, minus x bar is 6. Okay, so 6 square. So how much is this? 210 upon 5 is how much? 42, and 6 square is 36. So 42 minus 36 is square root of 6. Okay, which is equal to how much? 6 root 2.45. Okay, so standard deviation is equal to 2.45. Now you want coefficient of variation. Okay. Now what is the coefficient of variation says? It says find the sigma, find x bar and into 100. So coefficient of variation. What will be the answer? So I have coefficient of variation is equal to 2.45 upon 6 into 100. Okay. Can we do that? Coefficient of variation? Yes, clear, Zeba? Good, Sagar. Yes, Bala, I will be doing it. See, all this formula, the more you practice, the more you will be able to learn them. You don't have to sit one day and learn those formula. You have to solve as many sums as possible, so that once you are using the formula, it is going to be there in your mind. It will not go away. Okay, 40.83, everybody is saying? 40.83%. Yes, Ash Babu, right. Lakshita, Sagar, Shalini, Zeba, Nital, Harshita, Sagar, Shalini, Rohini, Liza, Jyoti, yes. Okay. Divya, there is no answers from you today. Now find the coefficient of variation of the following numbers. Okay, so we are trying to do similar sums so that you get a lot of practice. So what are we going to write? We are going to write x. How many numbers are there? 1, 2, 3, 4, 5. So this is 53, 52, 61, 60 and 64. So what is summation x? Summation x is how much? 53, 52, 61, 60 and 64. That is 290. How many numbers are there? 5. Okay. So my x bar, which is equal to summation x upon n, which is equal to 290 upon 5, which gives me 40, 57, 58. Okay, 58. X bar as 58. Now, I found x bar. Now I have to find x square. And I have to find the sum. X square. I have to find the squares of the number. So 53 square. 53, 2809, 52, 2704, 61, 3721. This is 3600, 64, 4096. Plus 3721 plus 2704 plus 2809. So this is 6409. Okay, just check whether these answers are correct. Oh yes, 16930, not 16930. 16930. 1, 2, 3, 4, 5, 10, 12. So now what is the formula? Formula says sigma is equal to square root of summation x square upon n minus x bar square, which is equal to under root of, what is the sum? 16930. How many numbers are there? 1, 2, 3, 4, 5. So 5 minus x bar is how much? 58. So 58 square. So what will be the value of sigma? Can you tell me? So this comes to 4.69. But what is the question? Okay, just pay attention to the question. They're asking you coefficient of variation. So coefficient of variation will be equal to sigma upon x bar into 100. So sigma is 4.69. X bar is 58 into 100. So this divided by 58, 8.08. Which is equal to 8.09. So I think A will be the correct answer. So that A will be the correct answer. Yes, Rohini, Nittal, Zeba, Vaishnavi, good. Pratidna, yes, 58, correct. Reza, Vaishnav, Bhargavi, yes. Yes, Sagar. Excellent. So we have understood this. Now, this is the example I was talking about, because if you directly remember this formula, that standard deviation of the first n natural numbers is square root of 1 upon 12 into n square minus 1. Now, what is the formula? It is saying that sigma is equal to square root of n square minus 1 upon 12. Okay, squaring both sides, I get sigma square is equal to n square minus 1 upon 12. If you are not comfortable with using the sigma, you can use s also. Okay, but I have constantly been using sigma, so I keep using this symbol. So if you want, you can write it as s square is equal to n square minus 1 upon 12. Now what they are saying is, if the standard deviation of first n natural numbers is 2, then the value of n. So they are asking you to find the number of natural numbers we have taken. So standard deviation is given to you as 2. So 2 square is equal to n square minus 1 upon 2. So what do? I cross multiply. 2 square is 4. 4 into 2 is 8. Okay. So 8 is equal to n square minus 1. Okay. Upon 12, not 2. Okay. Upon 12. N square minus 1 upon 12. So I do this, n square is 4, 4 into 12, which is equal to n square minus 1. So 4 into 12 is 48. 48 is equal to n square minus 1. So this minus 1 I take to this side, so it becomes n square is equal to 48 plus 1. Okay, so n square is equal to 49. N is equal to square root of 49, which is equal to 7. Okay, so n is equal to 7. So if I take the first 7 natural numbers and then I try to find the standard deviation, then in that case it will be equal to 2. Okay, so it's a good sum and very easy to solve also once you know the formula. Okay, now this is the sum which we are taking upon the properties of variance. Okay, we are taking the sum about the properties of the variance. Yes, Avdesh, Zeba, good. Swati, Nital. Now, what is the property says that if arithmetic mean and coefficient of variation are this, what is the variance of 15 minus 2y? So, let y be equal to 15 minus 2x. So, this is in the form y is equal to a plus bx. So, my a is equal to 15 and my b is equal to minus 2. Okay. So b is equal to minus 2. Now I have qy is equal to mod of b into q of x. I have qy, not q, this is okay. Y bar is equal to b into x bar. I'm thinking of quartile deviation here. Okay. So I have b is equal to minus 2 and a is equal to 50. Okay. Now what do I need to find out? I need to find out the arithmetic mean and coefficient of variation of x is given to me. So I have been given that x bar is equal to 10 and coefficient of variation is equal to 40. Okay. So I know the formula CV is equal to sigma upon x bar into 100. Now CV is already given to me as 40. Sigma I don't know, and what is the value of x bar? X bar is 10 into 100. Okay, so what do I get here is 4 is equal to sigma. Okay. 4 is equal to sigma. Now I am able to find out that standard deviation of y is equal to b times standard deviation of x. So y will be equal to, what is b? B is 2 into 8, 2 into 4, 2 into 4, which is equal to 8. Okay. So first we find out the standard deviation, and then we find out the standard deviation of y. Okay. Just check whether or not you've got this answer. Okay. But this is standard deviation. Now, what is the question? What is the, okay, why I took this particular question was that now I have found the standard deviation, but the question is asking for variance. Okay, the question is asking for variance. Now, what is variance? Variance is equal to standard deviation square. So, variance of y will be equal to standard deviation of y square. Now, how much did I get? Standard deviation of y was 8. So, it is going to be 8 square, which is equal to 64. So, variance of y is equal to 64 will be the correct answer. Okay, it will be the correct answer. Yes, everybody understood this? No, see, no. Lakshita, if AM and coefficient of variation of x are 10 and 40, of x does not mean x is 40. Arithmetic mean of x means what? It is x bar, which is given to you as 10. First thing is 10 because the word respectively is used, and coefficient of variation of x. So coefficient of variation of x is given to you as 40. Okay, they are given this. So x bar is 10 and coefficient of variation of x is 40. Okay. So coefficient of variation of x is equal to sigma upon x1. So you get standard deviation of x to be equal to 4. Now standard deviation of y is equal to b into standard deviation of x. So standard deviation of y is 8 into 4, 2 into 4, which is equal to 8. And but they want variance. So variance will be, variance of y will be standard deviation of y whole square. And so you get the 64. Okay, Lakshita? Yes? Yes, Nitya, very good. Yes, Zeba, it is the same thing that I just now explained, that arithmetic mean of x, that is x bar is given to you as 10, coefficient of variation of x is given as 40. Just put it in the formula, CV of x is equal to sigma upon x into 100, and from there we get sigma x as 4. Now standard deviation of y is 8, and then you get variance of y will be equal to standard deviation of y whole square, and you've got the answer. Okay, this is a comprehensive sum that I will take up before we end. So in this, what I'm going to do is for the 36 students of BBA students, the weights are given, that sum I'm taking, and on that, based on that, we're going to find out mean deviation about mean, coefficient of mean deviation, quartile deviation and coefficient of quartile deviation, range and coefficient of range, and standard deviation and coefficient of variation. Okay, so that once you do this sum, therefore you will be able to solve any of these dispersion problems. Okay, so I will just open the Excel sheet. Okay, so I have the class interval 44 to 48, 49 to 53, and for that my frequency was given to me. Okay, so frequency was given to us over there, 3, 4, 5, 7, 9, 8. Even this frequency we are calculating from the tally chart, all the raw data. From the raw data we prepared the frequency distribution, and from that now we are trying to find out mean deviation, coefficient of mean deviation, range, coefficient of range, quartile deviation, coefficient of quartile deviation, and standard deviation and coefficient of variation. So once I have this interval 44 to 48 and all, first thing I do is I find out the midpoints, and then because first thing I need to do is I need to find out the mean. So to find the mean, I must have f into x column. So okay, so midpoint and frequency. So what I do, concentrate on these three. So here what I have done, I found the midpoint, I found the frequency, and I found out f into x. So remember the formula for mean. Okay, remember the formula for mean is x bar is equal to summation x upon n. So this is 2611 upon 36, which is given me 61.42. So I have found the mean. Now I have to find the coefficient. Then I have to find the mean deviation. So for that, I will do x minus x bar, and I will find the absolute value. Okay. So what is that? X minus x bar and then absolute x minus x bar. So x minus x bar, because the mean is 61.42. So what will this be? This will be 46 minus 61.42, and similarly, and then I find the absolute value. So I get 45.83. Then I will multiply it by f. So remember, for the formula for the group data is then it is going to be equal to 1 upon n summation of x minus x bar into frequency. Okay, so this frequency is important. So I found out the x minus x bar, the absolute value of x minus x bar, and then I multiplied it by frequency. So I've got 235.82. Okay. So once I found the mean, now I'm trying to find this. I'm trying to find the deviation. Okay, mean deviation about the mean. So using this mean deviation about the mean, what I do have is mean deviation about the mean is on this. Okay, I am using mean deviation about the mean is 235 upon n. Okay, so I've already found out this mod of x minus x bar into f upon n. So that is 36. So I found the mean deviation about the mean. Then I find out coefficient of mean deviation. So then I find out coefficient of mean deviation, which is this number upon the mean deviation upon mean into 100. So what is the formula? Mean deviation, coefficient of mean deviation, I know is mean deviation upon mean into 100. So mean deviation was how much? 6.55 into 100 is 655.09 upon x bar is, this is my x bar. So I'm able to find this. Okay, so I found out mean deviation, and then I found out coefficient of mean deviation. Okay. Now for this sum, what is the standard? Okay, so I am able to find out mean, I am able to find out mean deviation, and I am able to find out coefficient of mean deviation. Now I want to find what? Range. Now range will be highest value minus the lowest value. So in this 43, now what I do is 43 to 48, then 48 to 49. So here I see the class is not continuous. So I must make it continuous. How do I make it continuous? By using the lower class boundary and upper class boundary. So I make the boundaries, and so the smallest value here will be 43.5 and the largest will be 73.5. So I have range as 73.5 minus 43.5, which is 30. And coefficient of range will be Q3, it will be L minus S upon L plus S into 100, which is giving me this answer 25.641. Okay, then I try to find out the standard deviation. Okay, so standard deviation, for that what I do is I have to use x minus x bar whole square. I have two options for the formula. Okay, for standard deviation. For standard deviation, I can have which is equal to square root of x minus x bar into f, summation of x minus x bar into f upon n. That is the basic formula for standard deviation which I have used over here. So here I am using x minus x bar and then I am using x minus x bar. Okay, so I have x minus x bar the whole square into f. Okay, I forgot to write the square. Whole square into f upon n. So I have done x minus x bar whole square into f and I've got this answer. And when I divide it by n, I get the standard deviation as 7.85. Okay, so this is my standard deviation. So I found the mean, I found the mean deviation about the mean, I found the range, I found the coefficient of range. Now I have found the standard deviation by using the basic formula square root of x minus x bar whole square into f, and when I make the summation of that upon n. Okay, so this is my standard deviation. Now coefficient of variation also I can find out because I found out the standard deviation and I can find out this thing. So coefficient of variation I know is nothing but standard deviation upon the mean into 100. Okay, so using that I have found out the coefficient of variation. Then I need to find the quartiles. Okay, I need to find the quartiles. So for quartiles I know that n is equal to 36. So for Q1 it will be equal to, because this is a group frequency, I will not use n plus 1 upon 4. I will use direct n upon 4. So it is 36 upon 4 which is equal to the 9th term, and Q3 which will be equal to 3 upon 4 into 36 which is equal to the 27th term. Okay, so 27th term, 9th term and 27th term. So for that I get this as 9th term will be how much? So for that I find the cumulative frequency. For that I find the cumulative frequency. Okay, I find the cumulative frequency. So here I have less than cumulative frequency. I have the less than cumulative frequency, and for that I want to find out where the 27th and where will the Q3 is 27 and Q1 is 9 are going to lie. Okay, so this is my, these two are important for finding the quartile deviation. So 9 is going to lie where? 9 is going to lie here and 27 is going to lie here. So you can calculate Q1 and Q3 using this, and then once you have found that, you have to find that you will find quartile deviation as Q3 minus Q1 upon 2, and coefficient of quartile deviation will be accordingly. Okay, so this is all that is there. So you already have the sum. Just put in the sum once again. So you can take down the sum, or you can just watch the video again where you can take down the sum. Okay. Yes, Bhargavi, the formula have already been uploaded for the last session. Okay, when we started the central tendency. So that PPT that is already uploaded. So you can take it and download it over there. All the formula are given. Okay. And in this PPT also the remaining ones. So when you want formula for quartile deviation, quartiles Q1, Q3, that you can see over there. And for this, you can see it in this PPT. All the formula are there. Okay. Yes, Lakshita, there are a lot of formula in standard in statistics, but these are very easy to understand. And once you practice 4-5 sums, you will never forget those. Okay. Yes, Sagar, I also enjoyed teaching you. And thank you, and you also have a great day ahead. Okay, yes, Bhargavi, yes. Okay, okay. Thank you so much.